Naxolo morongwa, nhlanhla. Nhlanhla naxolo morongwa. Guys, I'm not here to teach, okay? I'm just here to check on how everybody is doing. Nhlanhla hlophe. Great. Just checking. I'm here to check on how you guys are doing. How are things going school-wise? Syllabus, tests written yet? Like, are we anywhere close to writing term tests? Investigations, assignments, the works, what's happening? Otherwise, I'm not here to teach. I'm just here to check in on everybody and how they are doing. Maybe you can let me know in the comment section what grade you're in, what's happening currently in your respective schools. What topics are you guys currently doing? Just maybe if there's anything really in particular that you feel like is a challenge at the moment, maybe you can comment in the comment section. Maybe you can look at that particular thing. Just indicate the grade and indicate that specific section of work that you feel like is a pain. Otherwise, I hope you're well. I hope you guys have had a good week so far. It's Wednesday in the week, right? Monday, Tuesday, it's Wednesday in the week. How are we keeping? Mr. Green Bomber, the man from, I see your Zimbabwean flag there. You from Zim, Mr. Green Bomber. And are you a teacher perchance or not? Hello. Senzo Matipeta, Amy, Kenny Mtetwa, Mama D, Zahle Ncube, twin brother. How is everybody keeping? How are you coping? I do believe my network is okay as well. Which grade? Maybe I'll be writing next week, and I'm doing well on nature of roots. Is it? So, are you in grade 11, Nhlanhla? Is there any particular thing that's currently a challenge? When are you writing, and what are you writing on? What is this, like a term test, class test, control test that you're writing next week? I'm guessing you're in grade 11 if you're saying you're doing well on nature of roots. Yeah, I'm hoping the session that I did was okay. I'm not too shabby. Just remember that in the YouTube, the YouTube link itself, remember guys that the YouTube link as well is called Maths is a Game. We're still doing Maths is a Game there as well. And I think I uploaded both of those. Actually, not I think, I did. I uploaded both of those sessions on Nature of Roots. It's also called Maths is a Game. I think it's Maths is a Game 5 to 7. You'll see it's got a green-ish profile emblem on there. It's like the picture profile. Okay, everything that I do here is Maths is a Game. Maths is a Game. Maths is a game. So Nhlanhla, I hope everything of the best with that test of yours. That would be cool. Whoa, who is this guy? Powell, more fitness. Oh my soul, this is so cool. Nhlanhla, yeah, I'm sure you'll do wonders there. Do you know what topics you'll be writing on next week, Nhlanhla? Oh, no, not really. So there's no particular. No, you don't know. Okay. All right. So far, all the topics that you guys have covered at school are good. Exponents, sweet. Everything is sweet and lekker there. Exponents. From simplification of exponents, where there's multiplication and division, you find multiplication and division. And addition and subtraction, you find exponential equations, you lekker. Third equations, you are good. You were doing simultaneous equations. How is simultaneous equation treating? It seems like a lot of people are having a bit of challenges there. Let me just check if I can't maybe just entertain the masses with a simultaneous equation question. Let's see. I'll do this for you, Nhlanhla. Let's see. I think Nhlanhla, But I'm sure when you're good, I'm sure you're good. All right. With simultaneous equations, I once did a live session on simultaneous equations. You guys know that, I'm sure. For sure, you can go to my YouTube page. I have like a session that I did on simultaneous equations. But for the sake of remembrance, man, let's check one question here on simultaneous equations. X minus y. Hopefully you guys can see this. Hopefully the screen too shabby. Let's just see if I can clear this up a little bit here. Okay, here we are. X minus y is equal to 1. X squared plus y squared is equal to 5. So let's check this out. So you've got a linear equation and you have a quadratic type equation. All right. So obviously the first step is that we need to take the linear equation, all right, and we need to make either x or y the subject. The key here is to always make the variable the subject that basically does not have a coefficient, that has a coefficient of 1, right? That is the best sort of like approach, because that way we avoid having fractions, we avoid complications. So if we can always go for the variable that has the coefficient that is 1 and make that the subject of the formula. I'm sure you remember from grade 10 where you learned about how to make a particular variable the subject of the formula. So you always take the linear equation. So our linear equation here, we're just going to say this is equation 1 at the moment, and we have wonderful equation 2. So the equation that we take is going to be x minus y is equal to 1. And what we're going to do here, we are going to make x the subject of the formula. That means the relationship that x and y has is one of subtraction. We will transpose the minus y to the other side. That becomes 1 plus y. Okay. And then what we then do, very good, and you've got that down. You've got that down very well. Which I don't know what's happening here. You've got that down very well. Then we basically go ahead and we say this is equation 3. I know it was equation 1, but we call it equation 3 because we've made the subject of the formula x. Okay. Then what we do is we substitute. Now this part is very important. We are going to substitute equation 3, which is this equation, into the other equation that we did not change, which is equation 2. Does that make sense? So we're going to take equation 3 and substitute it in equation 2. And this is the essence of this thing. You are going to take the x plus y part of it, and everywhere where x is, you are going to substitute this expression 1 plus y in the other equation. So this is equation 3. We are going to take 1 plus y and substitute it everywhere where x is in the other equation, which is equation 2. So that's why I'm saying substitute equation 3 into equation 2. So what we then do is we go to this equation, we write it. Now we know that there's x squared, right? But in the place of x, what are we substituting? We are substituting 1 plus y. Where x is, we substitute 1 plus y. So we are going to write equation 2, but everywhere where x is, we are going to substitute 1 plus y. So in the place of this x, we are going to substitute 1 plus y. But remember that this x is followed by the squared. So that means where we substitute using brackets. And we obviously now are going to place the squared, okay, above the 1 plus y. Eric King, you are very much welcome. Thank you for entering into my live. We followed that but by plus. After the substitution in the place of x, it's followed by 1 plus y squared. So very good there, and I see you following on very nicely, and I see your comment there. Thank you so much. You are spot on. Followed by 5. Okay. Now, very importantly, let's not forget what happens after substitution. Okay, let me just show you the mark allocation. You get 1 mark for this, making either x or y the subject. You get your second mark from the substitution, substituting using brackets. Okay, remember where x is, we substitute 1 plus y in the other equation. Okay, yeah. And then that's the second mark there for substitution. Then this 1 plus y, what you do is that with this 1 plus y, remember, this simply means we open what? 2 brackets. Some people usually fall into the trap of wanting to square the first term and square the second term. Guys, we don't do that, right? Because where we actually do that is when we have a relationship inside the brackets of either multiply or divide. What I mean by this, guys, is that if it was 1 plus y squared, then obviously we would say the answer is 1 squared y squared, which is basically 1y squared, because the relationship is multiply. Or if the relationship is divide, then you can also do that as well, distribute the exponent. But if the relationship is plus, guys, or minus, we don't apply the square to the first term and the second term. We open 2 brackets, please, very importantly, and then we apply FOIL, okay? So that would be followed by our y squared that was there equal to 5. Then we need to play the distribution game, guys, very nicely. 1 plus 1 gives us 1. 1 plus 1 times y gives us positive y. Y times 1 gives us another y. And then y times y gives us y squared. So that is first terms multiply gives us 1. Outer terms multiply gives us positive y. Inner term plus y and 1 gives us another plus y. And then y times y. Remember, when we are multiplying same bases, we keep the base, we add the exponents. So that's where we get y squared. So that is the distribution of these 2 brackets sorted out. That's followed by what? By y squared equal to what? To 5. Then like terms, guys, we add the like terms, we transpose the positive 5, and we get the equation into what we call standard form. So 1 plus 2y plus 2y squared, we transpose the 5, it becomes negative 5 the minute it moves over across from the right hand side to the left, and then we make sure we write this in quadratic standard form. So 2y squared is first, followed by plus 2y, followed by the constant terms. 1 minus 5 gives us negative 4, which is equal to what? To 0. Now I'm sure you guys can see that there is a highest common factor in our quadratic standard form, which is 2. So what we do is we divide all of the terms by 2. Remember, if our highest common factor is a numerical constant term or a number, we divide by that number so that we can get our standard form in its simplified state. So that is y squared plus y minus 2, which is equal to 0. But remember, if there was a variable highest common factor, we would take out that variable, okay? We wouldn't necessarily divide by it, because if we divided by that variable, that would mean we are eliminating, or we are actually getting rid of one of our solutions. So remember, if the highest common factor is a numerical value, we will divide each term in the equation by that highest common factor, okay? So we divide that by 2, becomes y squared. We divide that by 2, becomes y. Divide that by 2, it becomes negative 2. And we divide the 0 by 2 as well, but that becomes 0. Okay, so that's very important. Example on the side, please. What do you mean by example on the side, please? Okay, so basically what I'm saying is, okay, we have a highest common factor here, which is 2. So what we do obviously is we divide each term by what? By 2. And then obviously we get that y squared plus y minus 2 is equal to 0. What I'm saying, if let's say for instance there was a variable, I'm just gonna give this to you as an example. Okay, this is an example, guys, right? Just an example. So in this case, you have 2y cubed plus 2y squared minus 4y is equal to 0. So what you can see is that your highest common factor here, you have a highest common factor numerical value, which is what? Which is 2. And you have a variable highest common factor, which is y. Okay, so in this situation, what we would do, we would actually take out the highest common factor. Okay, we wouldn't divide each term by the variable, because if we were to do that with a variable, it would eliminate one of our answers. And I just want to show you what I mean by that. Okay, so then we would be left within the bracket with y squared plus y minus 4, which is equal to 0. Okay, and of course then what we would do is we would say 2y, we'd keep this 2y, and then the y squared we would factorize y squared plus, oh sorry, that wouldn't be minus 4, that would be minus 2. I hope you guys get the point. Then we'd open 2 brackets. Okay, we get y, so that would be plus 2 minus 1, which is equal to 0. Then that would afford us, okay, because we have a product of factors, then we would say 2y is equal to 0, or y plus 2 is equal to 0, or y minus 1 is equal to 0. Okay, because someone else would think that we divide by 2y. If we would divide by 2y, that would mean that we would be eliminating this answer completely. That is why when you have a variable highest common factor, you don't ever divide by it. You take it out so that that answer can be able to be there. Okay, I hope that makes sense. Derek Hansen, just hang on. Okay, I just want to finish off this simultaneous equation because it was a request from someone else. I'll solve an inequality for you so that you can see how it's done. Okay, so let's go back here. So Subani, I hope you got, I can see you got that very well. So if we factorize this, because we're in the standard form, we factorize this, we open 2 brackets. Okay, remember, if the negative sign is there, it means that the signs in our bracket are different. Okay, so we're going to have 1 plus and 1 negative, and then remember that the factors of 2, which we multiply, give us 2, but when we add them, they give us the coefficient, which is 1. That would be plus 2 and negative 1. And you can quickly check this before you even go and write the answer. Remember that 2 times negative 1 gives a negative 2, which is 100% correct. And then plus 2 minus 1, if you add, gives you 1, which is the coefficient of y. Okay, then we finish off. Y plus 2 is equal to 0, the 0 factor law. Okay, when you have product of 2 factors equated to 0, you can take this bracket equate to 0, that bracket equated to 0. Remember, this only works if there is a 0 on the right hand side. If there was another number, we wouldn't take the bracket and equate it to the other number. This only works with when there is 0 on your right hand side. That's why we call it the 0 factor law. Okay, so that was our standard form. Those are our factors, and then our solutions for y is equal to negative 2, or y is equal to positive 1. Remember, we are not done. We had initially gone ahead and said let x is equal to 1 plus y. Remember, we made x the subject of the formula. Now this is all ready and prepared for us to get our x values by substituting those y values we had just received. So we finish it off now. After finding y, we go and find x is equal to 1 plus, in the place of y we substitute negative 2, or in the other one, x is equal to, in the same equation, x is equal to 1 plus y, we substitute in the place of y positive 1. 1 plus 1. Then 1 plus minus 2, remember that's 1. Positive times the negative gives us negative 2. That gives us x is equal to negative 1. Or x is equal to what's 1 plus 1? That gives us 2. So, all in all, when x is negative 1, the corresponding y value is negative 2. Or when x is equal to 2, the corresponding y value is 1. So you can actually represent these answers as coordinates, okay? Because we have y is equal to negative 2 and y is equal to 1, x is equal to negative 1 and x is equal to 2. And why we can represent these as coordinates is because these are actually a representation of what we call the points of intersection. Okay, so you can actually express them as such and leave them as such, okay? Derek Hansen, you want me to do the inequality that you've just written down, 2 into x plus 2 greater than x squared minus x plus 6. This is the inequality for once you are done assisting the other person. Okay, I'll help you out with that. So my good friend, my beautiful, amazing friend, my handsome, amazing friend there, who had initially asked me to do not that you had asked me to do simultaneous, but you said you were doing simultaneous. I hope we are on the same page. Thank you so much for asking or saying. All right, and please guys, let's just check the mark allocation. So like I said, making x or y the subject, 1 mark. Substituting the expression in the place of the variable that's given, that's another mark. And remember, substituting using brackets, you're substituting in the other equation, that's a 2nd mark. And then your simplification that leads to a standard form that is simplified is another mark. Factorizing, okay, where factorization is possible, factorizing. Your y values, correct both of them, and then your corresponding x values, correct the both of them. So this is a typical 1, 2, 3, 4, 5, 6 mark question. And sometimes, depending on the particular examiner, sometimes they allocate simplification marks. It just depends, all right, on who is basically allocating the marks. So guys, this is a typical nice question. I mean, guys, 7 good, 6 marks, all right? And remember that for grade 11, if you are writing a full paper 1 for grade 11, your algebra, your equations and inequalities actually account for 45 marks of the paper 1 question paper. So if you think about it, this is 6 marks, guys. You can work out the percentage. 6 divided by 45. How many marks is simultaneous equations worth? All right, this is 6 marks or 7 marks sometimes. Okay, these are 6 marks that you can get. These are freebie marks, guys. Okay, so let's never miss out on these marks, and I hope you guys can just flow in the marks that are afforded by those simultaneous equations. Okay, I hope that was clear, and I hope my good friend there, the one who indicated Unhlanhla, you are spot on. You are flowing very nicely in those questions. Let's look at Derek Hansen's question. Derek asked me to do an inequality. All right, so let's look at this inequality. Okay, so this is inequalities. Now there's a trap that people usually fall into when they solve for quadratic inequalities. They tend to apply. You are very welcome, Tlantla. You're very welcome. Very, very welcome. When people solve inequalities, they tend to fall into this trap of treating an inequality as you would a normal equation. And then they basically do the same things that they usually do to an equation. And then they arrive at a certain place and they conclude and they think they are right. So let's just take it one step at a time and just make sure that we are following the mojo. All right. So first and foremost, we have 2 into x plus 2 greater than x squared minus x plus 6. Guys, for inequalities, let's look at a recommended method. Step number 1. If your inequality is quadratic in nature, meaning it's a quadratic trinomial, what we need to do is we need to get that quadratic trinomial into standard form. By that I mean we need to get it into the form of ax squared plus bx plus c, and depending on the inequality sign, if it's greater than, then obviously it's greater than. If it's greater than or equal to, then it's greater than or equal to. If it's less than, it's less than. If it's less than or equal to, then it's less than or equal to. But on the other side, there has to be 0. That's what I mean by quadratic standard form. So if you look at this inequality, it is not yet in quadratic standard form. But what we can see is that x squared minus x plus 6 is already in the standard form state, but it's just that these two need to be transposed. So what we must do is take the 2 and distribute it into the x and the 2, because the relationship between this 2 and this bracket is multiply. I repeat, the relationship between the 2 and the brackets is multiply. You have a monomial, 1 term, multiplied by a binomial. There are 2 terms inside the bracket. Bi meaning 2. So 2 times x We distribute, this becomes 2x. 2 times plus 2, that's positive 4. Okay, I hope so far we are together. Greater than x squared minus x plus 6. Okay, we are getting close to getting our equation into standard form. Now, here's the thing. You have 2 choices, okay? And I'm going to show you both sort of like approaches depending on who the student is. A student who is someone else may decide to take this x squared and move it over to the right-hand side, to the left-hand side, because they are so used to that. But remember, when you transpose things to the left-hand side, what happens? The signs of the terms change, okay? So you have that choice. It's something you can do. So 2x plus 4 will stay that way. But the x squared, the minus 6, and the plus 6, if I decide to transpose it, remember, the signs of the terms will change. So here we go. We have a negative x squared, which is my first term on this side, followed by minus x, which becomes plus x. But remember, it has a like term, so I'm going to just join it with that like term, which is positive on the left-hand side. It's positive 2x. This 4 is positive already. If I take this positive 6 here and I transpose it to the left, it becomes negative 6. And remember, the inequality sign at the moment is facing in that direction, opening the mouth. It's like, you know, I don't know if you guys used to play the game Pac-Man, but it's opening its mouth towards the food, right? Yes. Okay, so it's opening its mouth towards these terms. And on this side, now we are left with what? With 0. Are we together? So far, are we good? Because my objective, I'm wanting to get the equation into standard form. So I'm here right now. Okay, now I'm going to add the like terms because I want to get this equation in standard form. So I get negative x squared. What's x plus 2x, guys? Let's see in the comment section. Maybe you guys can help me out. What's x plus 2x? And then what's 4 minus 2? So let's start with x plus 2x. X plus 2x will give me, thank you, Sbani, it's plus 3x. And then 4 minus 6, guys. Thank you, Low-Key Cat. You guys are good. You guys are phenomenal. Okay. Okay, the negative x squared stays as a negative x squared. But remember, x plus 2x, when we add like terms, the variable stays the same. We add the coefficients, meaning remember, before this x we have a 1, positive 1 coefficient, and then before this x we have a positive 2 coefficient. So the variable will stay the same. You add the coefficients. I get 3x. Okay, just wait a second. Then what's 4 minus 6? Thank you, Quantum. It's negative 2. We have greater than 0. As the question had greater than 0, we still have greater than 0. I hope you guys are with me so far. Now, the next step. There's a negative x squared plus 3x minus 2 greater than 0. What we usually like in our standard form is when the a is a positive value. In other words, the coefficient of x squared must be a positive value. What do you see here? Currently, the coefficient of x squared is a negative value. So what do we do? Thank you, Sban. We divide by negative. What happens in an inequality when we decide to divide the highest degree of our exponent and all the rest of the terms by a negative? What happens to the inequality sign? Thank you, Khabo. It changes direction. I repeat, it changes direction. Luyoloma does, you are spot on. Mbali Makubu, you are a hero. You guys are heroes, man. You guys are amazing. Okay, so what we do now, I want to note something here. If you decide to do this to show your division, in the moment that you show your division, the inequality sign's direction must change in that very moment. If you decide to show your division of the negative, the inequality sign's direction must change in that moment. Okay, please. Then this becomes x squared minus 3x plus 2 less than 0. Okay, I hope my good friend who actually asked me to do this question, Derek Hansen, you are here and you can see what movement we have taken from the beginning of the question to this point, and we are together in this thing. If there's a place where you guys feel lost, please indicate to me in the comment section. But if we are flowing together, I hope you guys yeah. So when we divide by a negative, this is the point. When we divide by a negative, that's when the inequality sign's direction changes. Okay, division by a negative leads to the change of direction of the inequality sign. Please hold on to that for dear life. You guys learned this even earlier on. Let me just want to grab a piece here. When you were in grade 10, you remember you guys did these questions in grade 10. You solved linear inequalities. In grade 11, you solved quadratic inequalities. But in grade 10, you still need to remember this just as well. You guys solved linear inequalities. What happened? You would usually transpose the constant term. Then when you get to this place, you would divide by the negative. When that happens, what happens to this inequality sign's direction? It changes. The moment you divide by a negative, the answer, -3. Why am I saying -1? Because the coefficient of x is -3, and you get x is greater than negative divided by -1/3. This is what you guys did in grade 10. Okay, so let's not forget that a division by a negative sign leads to the change in direction of the inequality sign. Very important note. So my dear friend Derek, I hope we are now safely nestled in the same place and we can comprehend the same thing. Okay, then 2. After we've gotten the equation in standard form where a is positive, we then have to factorize. This is very key. We factorize. In some cases, you may find in certain inequalities, factorization may not be possible. So one will have to use the quadratic formula because factorization is not possible at all. Okay, so in cases where factorization is not possible, we can go ahead and use the quadratic formula to find or to be able to get what we refer to as our 3 critical values. And I repeat, critical values. These are what we typically know as the solutions of x, but they are not the solutions of the inequality. The critical values are what we refer to as the solutions of x for the quadratic inequality. They are also referred to, if we are looking at a expression graphically, they are also referred to as the x-intercepts, as they divide the function into different parts. They are critical values. We refer to them as the solutions of x. They are also referred to as graphically the x-intercepts. So let's go here. Let's factorize. Okay, because that's the next step. We factorize. So here the factors then would be, all right, obviously we have x and x. The positive means that we have the same signs inside the bracket. Remember, a positive constant means same signs in the bracket. Same according to who? According to the middle term. So that means we have minus, minus. That's why we know that it's same signs according to the sign of the middle term. Then the factors of 2, 2 and 1. Yes, Khabo. Critical values are where y-axis is 0. Oh. Okay, yeah. where y is equal to 0. In other words, you want to say where y is equal to 0, not where necessarily where the y-axis is 0. It's where y is equal to 0. That's where the critical values are located. Okay, so we then write, please guys, we must write these letters CV to indicate that we are not saying these are the solutions for the inequality. We are saying that these are the critical values of the inequality. What are they? X is equal to 2 or x is equal to 1. This here is very critical. You must make sure that you write CV, because you are indicating to the person who is marking your paper that you acknowledge that these are not the solutions, but they are the what? The critical values. So we write CV for short, critical values. Are you with me? Yes, maths is a game indeed. Then, after doing that, after the CV, we must represent our answer graphically. We represent graphically what we mean by our critical values. Very, very graphical. We represent graphically what we mean by these critical values. So what you do is you go ahead, okay, there's the parabola approach where you can just simply say, here is my, you remember we changed the negative to positive. In our standard form, we take after what we have in the standard form to basically come and represent what we mean graphically. Then x-intercepts critical values. The smallest critical value is 1 and the biggest critical value is 2. Now, let us come here, because this here now becomes our focus as to how do we understand, we write the answer for this particular inequality. So we are told here that the product of these factors should be, as it says, should be less than 0. But remember, this represents the output. In other words, it represents the y values. Now, I want you to think with me for a minute here. When we say less than 0, for the y values, our output, we actually mean that the y values must be negative. And you ask yourself the question, where in your graph, in your Cartesian plane, are the y values negative? Now, I'm sure if you know the y-axis, this is the y-axis, and above the x-axis, you have positive y values, but below the x-axis, you have negative y values. I hope you guys understand that. Above the x-axis, we have positive y values. That's why here you have 0, 1, 2, 3, 4, 5. These are positive y values. Below the x-axis, you have negative y values. Negative y values. So less than 0 speaks to negative y values. Less than 0, meaning the output y values, the y values must be negative. That's what this means. So that is why we interpret less than 0 to mean the following: below the x-axis. For a concave up graph, we know that less than 0 means below the x-axis. Now, below the x-axis means between the CVs. And guys, this is very key. BB. Less than 0 means for our output values, y, which is y must be negative. My question is, where is y negative on the Cartesian plane? It is negative below the x-axis. So below the x-axis, what do we mean below the x-axis? That means for x, it's between the critical values. So our answer is actually located here. Do you see what I'm shading? Okay. Less than 0, below the x-axis, meaning between the critical values. That's where my answer is located, between the critical values. So in other words, two ways to write the answer. You can either say x is an element of, now this is less than, there's no equal, so that means open bracket 1 to 2. This is one way you could write the answer. We call this interval notation. So you could write your answer in interval notation, or if you're used to this way, you can actually say 1, 2, x in between, and then the inequality sign direction, all towards the right. Buckman is opening his mouth towards the right. This means x is x is greater than 1. X is greater than 1 is this side, but x is less than 2. So even though it's greater than 1, it's less than 2. This is in between, below and between. I hope you guys get this. It's so beautifully well said. Below and between. Less than 0 means below the x-axis, because that's where our y values are negative. So below the x-axis means between the critical values, because our parabola is concave up, because remember at this stage our a value is positive. So we represent the graph, represent it graphically, we note our critical values 1 and 2, and then we can either write our answer in this form, in the inequality form, for below and between. Guys, there's 2 marks allocated to this thing. The answer has 2 marks. Okay, 1 mark for for our factors, 1 mark for our standard form. All right, and if they decide to allocate any other marks, they will do that if they want to, you know. But remember, when you write these, you write CV, please. Okay, please guys, for the person who's asking, Derek Hansen, please listen to this. Remember, x, when we are saying x is greater than, remember the x, this sign is opened, the mouth of Pac-Man is opened towards x. So when we read it, we say x is greater than 1. Okay, but remember, at the same time, x is less, because this is opening its mouth towards the 2, not towards the x. Here, that's why the reason why you say x is greater than, it's because this inequality sign is opening its mouth towards the x. So we say x is greater than 1, but x is less than 2. And why we say less than is because this x is not, this inequality sign is not opening its mouth towards the x, but it's opening its mouth towards the 2. So therefore we say x is less than 2. Please understand that, Derek can understand it well. So we say x is greater than 1, because really it is, right? Because this direction of the inequality sign is opened towards the x, but x is less than 2. Very critical, very important, this thing that I've just said. Okay, so now do you understand, Derek? Because I get what you're saying. The 2 things you couldn't understand is why the signs change, meaning the inequality sign. So now you understand that the inequality sign changes the minute we divide the degree of the highest exponents by a negative. Okay, then the direction, in that moment we divide by a negative, the direction of the inequality sign needs to change. Okay, and then last but not least, I hope you understand now how then we represent the answer. Okay, guys, I just want to, because remember I spoke about below the x-axis and between the critical values for when the factors are less than 0. Let's just entertain something here. Let's just say we got to a place where we got this, but then we didn't have less than, we had greater than 0. Okay, I want to speak to what this actually means, the greater than 0 part. So please take note. If it was greater than 0, what does greater than 0 means? It greater than 0 Okay, remember this is the output y, so that means our y value must be, if it's greater than 0, it means the y value must be positive. Then you ask yourself, on the Cartesian plane, where is y positive? Above the x-axis. But above the x-axis, okay, remember we would write our CV, critical value, and say x is equal to 2 or x is equal to 1. Parabola state, we have that. We have the 1 and the 2. This time round, we are saying greater than 0, which means y values must be positive. Where is our y value positive on the Cartesian plane? It's positive above the x-axis. Guys, you saw most, I did indicate that our y values are always positive above the x-axis. They are never positive below the x-axis. So we are looking at above the x-axis. So our focus, when we look at greater than 0, we're focusing on above the x-axis. Now please take note of something. From negative infinity to 1, this here is above the x-axis. You see, I'm shading above only. From 1, and the function exists there above the x-axis. From 1 to 2, the function only exists below. But we're not looking at below. We're not interested in below this time round because we are focused on above the x-axis. From 2 to infinity, we have above. Are you with me? So therefore, here in this case, we say above the x-axis, away from the critical values. And check this out, AA. You see, for less than 0, we have BB, below and between. For above or greater than 0, we have above and away. So the answer here will be x is, all the values this side from 1 are less than 1. All the values of x in this side are less than this value, less than 1, less than this critical value. Or we use the word or, guys, to separate, because these are separate. This side, x is greater than 2. That would be our final answer. 2 marks. Guys, we get 2 marks for writing the answer correctly, 100%. 2 marks. But if you stop there at critical values and you think, that's my answer, hey guys, you lost 2 marks, gone. 2 marks gone, just like that. So please let us cultivate this thing. Like I said, greater than 0 for 2 critical, and this is the thing, okay? This only applies for 2 different critical values. AA and BB applies when you have 2 different critical values. I repeat, 2 different critical values. Then you will have a situation of AA or BB. And remember, guys, if there was less than or equal to 0, then in my answer I would put equal as well underneath those less than signs. And if it was greater than or equal to 0, I'll put equal as well under my inequality signs. All right? Okay. Otherwise, this is how it is with inequalities that have 2 different critical values. Okay. All right. Derek, I hope Derek is fully answered with regards to his question. Okay, so yes, standard form. And our standard form must be where A is positive. We factorize, if it's factorizable, we get our critical values. Please, we write CV. Don't forget to write CV. And then last but not least, you represent graphically. And then 5, don't forget to write down the answer. Don't forget to write down the answer. Okay, you're very welcome, Derek Hansen. You are very welcome. But please note, This is for two different critical values. I did not explore when you have one critical value for your inequality. All right, but yeah, I will stop where people have asked me questions. Okay, any other questions, guys? Any other burning sensation questions that you guys have? Under the grade 11 syllabus, anything that you guys I looked at a question that has to do with simultaneous equation as I was asked as per request. Okay, and I think whoever was asking that question was clarified. Anything else in the grade 11 topics, something that maybe is still amiss, that you feel like is still a problem, a challenge, it's giving you nightmares, you're not sleeping very nicely because of it, please guys indicate. More than happy to help if there's help and assistance that's in there. So thanks for the teaching. I'm going off now. No problem, Tlantla. Thank you so much. You're welcome, bruh. You're welcome so much. Have a good one. Have a good night. Thank you. I'm happy to help, guys. I'm very happy to help, Very happy to help. Yeah. So if there's nothing else then, guys, then I'll be off myself. Please tell us more about the types of graph, parabolic, hyperbolic, etc. Yabona now, Esbani, when you are speaking under a grade, what is it, a grade 12, what you might call Esbani Mnigati, you wanted to know about the different types of graphs that exist. The thing is, I don't want to be confusing a lot of people here, but Sbani, for you, let's do it for you. Okay, you want to know. Okay, so let's look at the different types. Let's try and get a window written up so that we can identify. So we have what we refer to as a linear function. Okay, you still remember linear functions, but linear function. Okay, let's first look at the standard linear form of a linear function. Standard linear form of a linear function is y is equal to, now depending on who you've been taught by, y is equal to mx plus c. All right, that's a standard linear form of a linear function. M, you should know what it stands for. C, you should also know what that stands for. Hopefully, I hope you know. Okay, M. Okay, so M stands for, M is your gradient. Ne? Yeah, M is gradient. And remember, your gradient can either be greater than 0. Okay. If M is greater than 0, the straight line function is an increasing function like that. M less than 0, straight line function that's decreasing like that. M is equal to 0, you have a horizontal straight line. And then lastly, M is undefined. So here's the thing, if your straight line function is horizontal, then it's going to be y is equal to some constant value. And this c can be any real number, okay? Any real number, okay? If it's undefined, the gradient is undefined, then the equation uniquely has the function x is equal to c. All right, it has a subject that is x, it's equal to c, and we know that c will be an element of any real number. Okay, So that's when m is undefined. Whereas when m is equal to 0, it's a horizontal straight line. When m is undefined, it is a vertical straight line. So if the gradient is positive, it's an increasing function. As x increases, y increases. If it's a gradient that is negative, it is a decreasing straight line. As x increases, y decreases. M is equal to 0, horizontal straight line. M is undefined, then it's a vertical straight line. Okay, then c, which is this constant. What does c stand for here? The c is what we refer to as the y-intercept. Okay, and obviously that's when x is equal to 0. We refer to our c value as the y-intercept. Very importantly, for a straight line, c is the y-intercept. This only applies to this general form of y is equal to mx plus c. The c is referred to as the y-intercept. Okay, very, very important. So if you want to know what the equation of the y-intercept is, you can simply just write down that for yourself there. Okay, so that's just like just the sort of like an intro to understanding, because once you understand the form, you understand what the m stands for. It's a gradient. Okay, so gradient represents the steepness of a graph. Okay, that's what gradient is. And then c represents the y-intercept. In other words, where the graph cuts the y, where the function cuts the y-axis. Okay, that's what we mean by y-intercept. That's where the graph, that's where the function cuts the y-axis. So that's where the straight line cuts the y-axis. Okay, all right. So, these are the forms, guys. This is the shape of the function depending on the value of m. Okay, then you have your parabola. All right, I'm not gonna go too deep today, Sbani. I'm gonna develop this as days go by for you. Let's just start here for today, and then you can just digest that for today. Hopefully you're still here, Sbani. You did not disappear. Parabola or quadratic function. So a parabola function, we usually call it a quadratic function. That's another name for it, right? Parabola, or we say it's a quadratic function. The form of the parabola function. Now here's the thing. In grade 10, okay, and what's beautiful here is that this here stays the same throughout all grades, grade 10, 11, and 12. So your linear function basically does not change. It's always y is equal to mx plus c, and m and c mean the same thing. So in grade 10, your parabola function was y is equal to ax squared plus 2. And what makes it quadratic is this x squared term. That's why we refer to it as a quadratic function. Okay, so ax squared plus 2. Now you need to understand, Kengoku, for yourself that in grade 10, this here in grade 10 used to represent our y-intercept for the parabola. And it also used to represent the y-coordinate of the turning point. Okay, because remember, a parabola has a turning point. Okay, so this form in grade 10, this 2 value, like I said, means two things. It means the y-intercept, in other words, where the graph cuts the y-axis. And then it also, this q value is the y-coordinate of the turning point. Okay, so hopefully you are good there. Then let's come to this a. This a, right, helps us with the shape of the graph. Okay, so in other words, if a is greater than 0, in other words, it's positive, then our function took on a smiley face. It's like a smile, because when you are positive, guy, what happens? You smile, right? So it's a smiley face. It's concave up. The graph would be a concave up graph. And remember, there's a place where it turns, which means it has a minimum value. Thank you so much, Ndombozo. So it has a minimum value, right? Because it turns and it has a lowest point, which we refer to as the minimum. So when we talk about A being positive, we're always referring to the lowest point. There's the lowest point of the graph, which we refer to as the minimum, the lowest point. Okay, but it's a smiley face, it's concave up because A is positive. So remember, when you're positive, you smile, right? So that is the shape of the graph, because A helps us to identify the shape of that particular quadratic function. When A is less than 0, then obviously less than 0 means negative, right? So the function, the shape, concave down, all right? Yeah, sad face, negative. When you are, it's not a smile, it's a sadness. Yeah, because when you are negative, surely you are sad, you are not happy. You feel that. But this here has a maximum value, meaning the turning point is at the top. It has a maximum. So if I had my grade 11s here, I would then be able to explain to them, because the grade 11s, when they start with quadratic equations, they start doing something that we refer to completing the square of a quadratic expression, and then they're supposed to find the minimum and the maximum. All right, so this all speaks to that. Okay, they can identify with that where this is concerned. All right, but I'm not going to go too deep. I'm just going to leave it here. Okay, so please, man, if you look at this quadratic function, this quadratic function form, ax squared plus 2 y-intercept and the y-coordinate of the turning point, that was for grade 10. The A helps us with the shape. All right, and also when we talk about the transformation of the graph, then we start looking at other things. I'm not going to look at the transformation for these graphs for today. Today I'm just going to talk about what these respective things mean when you write down the form, the standard form of each quadratic function. Then I will develop it in another session for you, Sbani. Hopefully you can bear with me with that, because after all, this is a question that you asked. I can't be turning this into a full-blown lesson or just like that, if you know what I mean. So that was in grade 10, and then I just want to move on a little bit. In grade 11, we extended the form of the quadratic function. Okay, we had what we refer to as the quadratic form. Now also another thing, Sban, they tend to now use this thing here. All right, and I just want to say as well that when you start seeing this, remember this is what we refer to as functional notation. This is just another way of saying y. Y just has a fancy sort of like complicated way of being able to represent it. We refer to it as the functional notation f of x. Okay, the letters can be changed. It can be g of x, can be l of x, can be p of x, can be t of x. All in all of those things mean y. That's what it means. It just stands for y. Okay, so if I don't say y is equal to x squared plus bx plus c, I can say f of x is equal to, I can say g of x is equal to. And sometimes they will change the letters so that they can identify different functions on one system of axes. So if in your Cartesian plane you have different graphs drawn, they will usually say the one is f of x, the other one, maybe if it's a straight line, they'll say it's g of x, and the other one, they will say it's h of x. That is just a way that we are able to differentiate between different functions. We use functional notation, okay? So anyways, in grade 11, you then got an extension, y is equal to x squared plus bx plus c. Furthermore, you even learned about the turning point form of the very same function, where you can represent the function of a quadratic function and restate it in another form. We refer to this as the quadratic form. Then we refer to this as the turning point form. Right, because from this one we can read the coordinates of the turning point just from the expression or the function itself. This one we cannot read the coordinates of the turning point, but here we can, but here we can't, but here we can, but here we can't. All right, yeah. And then you can look at A, P, and Q and what they mean as far as your transformation of the graph. I'm not going to go into that. Like I said, I'm going to touch on transformation and other things at a later lesson or at a later session when I answer other things. So that is parabola. That is just a taste of parabola, just a little bit. Then you can go over to another type of function which we refer to as the hyperbola. Guys, this is very much impromptu because Swani just asked the question and me, I'm just literally going off the things that I can recall. It's been a while since I've taught functions. Last year was the last time I taught functions in their full-blown state, if you know what I mean. Y is equal to x a over x plus 2. This was in grade 10. All right. Y is equal to a over x plus 2. Q here represents what we refer to as the horizontal asymptote. Horizontal asymptote. What is an asymptote? An asymptote is a boundary line where the function does not exist. Okay, asymptote. Asymptote is a boundary line where a function does not exist. In other words, you cannot find the function existing on that boundary line. Okay, asymptote. So there is a horizontal asymptote. So in your hyperbola, you actually have two asymptotes. Okay, there's the horizontal asymptote that is given by the value of q. So the equation of the horizontal asymptote will be equal to y is equal to q. That q value can be any real number. Because remember, when you have the actual function, you actually have an actual value that is standing in the place of where q is. But no, that q value is what we refer to as the asymptote. What is the asymptote? A boundary line where the function does not exist. That's an asymptote. Okay? Yeah. So the horizontal one is y is equal to q. And funny enough, if you look, when we were doing a straight line function, what did we say a horizontal line? The horizontal line, it has the form y is equal to some constant value. All right. So it makes sense that your horizontal asymptote will be a horizontal line, but it's a boundary line where the function does not exist. It has this equation and it's denoted by the value of q in your hyperbola function. This is your standard form for a grade 10 hyperbola. A over x plus 2. What does this q stand for? It stands for your horizontal asymptote. Okay, please guys, that's what it stands for. Then what about A? A gives us the position in the quadrants where function is found. Okay, and these quadrants, they depend on the asymptotes. They depend on the asymptotes. So you must have your asymptotes drawn in first before you can then identify the quadrants on your Cartesian plane. Right, very important. So in other words, when a is greater than 0, you can expect to find your function in the first and third quadrant, depending on the asymptotes. But if a is less than 0, you can expect to find your function in the second and fourth quadrant. And this is very important. So once again, okay, and then this x value here, the denominator expression equated to 0, the solution gives me the vertical asymptote. The solution. So if you take the expression in the denominator equated to 0 and then solve it, that is the vertical asymptote of our function. Okay, so the vertical asymptote will be expressed by the expression of the denominator equated to 0. You solve that, you have the vertical asymptote. So that's why in grade 10, for instance, in grade 10, you had a vertical asymptote of x is equal to 0 because the expression in the denominator is just x. If you equate that to 0, you have a vertical asymptote of x is equal to 0. Makes sense? Because remember, a vertical line has the equation x is equal to some constant. Okay, so I hope this slaps hard, because now you get to understand why we are saying a horizontal line has the equation y is equal to some constant, whereas a vertical line has the equation x is equal to some constant. Now all of a sudden I'm saying there's a horizontal asymptote which is denoted by the value of q. Y is equal to q. It's a horizontal line, horizontal boundary line, when the function does not exist. Then there's a vertical asymptote given by the expression in the denominator equated to 0. You solve it, you get the vertical asymptote. So vertical asymptote in grade 10 was always vx is equal to 0, whereas the horizontal asymptote was y is equal to whatever that value of q is. If it was 7, then it's y is equal to 7. If it was -3, then it's y is equal to -3, and so it goes. So that's why we say q is an element of any real number. Okay, and then a, guys. If a is greater than 0, you can expect to find the function in the first and third quadrant. If a is less than 0, you can expect to find the function in the second and fourth quadrant. Very, very important. And I just want to show you this just as per example. If we know that these are the if these are the boundary lines, let's say the y-axis and the x-axis are boundary lines. So if a is greater than 0, this is what I typically know as this is my first quadrant, second quadrant, third quadrant, fourth quadrant. That's if for real the horizontal asymptote is y is equal to 0, whereas the vertical asymptote is x is equal to 0, which means my y-axis and my x-axis are asymptotes. So this is my first, second, third, fourth quadrant. What did I say? If a is greater than 0, you can expect to find the function in the first and third quadrant. A is greater than 0, where do you find the hyperbola? It's in the first and the third quadrant. If a is less than 0, where do you expect to find the function? If this is my horizontal asymptote, my y-axis, and my x-axis is my vertical asymptote, then you can expect to find the function here and there. Okay, yeah, second and fourth. So first, second, third, fourth, anti-clockwise, guys. First, second, third, fourth. Okay, but remember, I said and I emphasize that all of these quadrants, they depend on the asymptotes. So you need to first sketch in your asymptotes when you are sketching a function. Then you are able to draw the function in accordance to the quadrants that are there. Then last but not least, okay, so remember, I did not explore the grade 11 hyperbola, but we'll get there, right? Okay, so I'm just touching on these. It's a touch and go introduction. We'll unpack it even more. What about exponential equation? Exponential function, sorry. Okay, so your exponential function has the form y is equal to ab to the power x plus q. So this is the grade 10 hyperbola function. And once again, this is grade, the grade 12 learner has asked me a question about the 4 different types of functions. So I'm just doing a summary on those, okay? Nothing in depth, just sort of like introductory, sort of like understanding of the forms of each function and just basic things for introduction. Okay, so grade 10, y is equal to ab to the power x plus q. This q, what does it stand for? Once again, horizontal asymptote, because an exponential function has one asymptote, guys. One, not two like the hyperbola. It has one asymptote, and it's only the horizontal asymptote, which means y is equal to some q value, where q is an element of real numbers. That is always our horizontal asymptote. This q value represents the horizontal asymptote. Then, what about the a? When a is greater, and I repeat, when a is greater than 0, then the function will be above the x-axis. When a is less than 0, then the function will be found below the x-axis. So this speaks to position of the function. Okay. A speaks to the position of the function. So depending on the value of a, if a is a positive value, then expect to find the function above the x-axis. If a is less than 0, then expect to find the function below the x-axis. Okay. Yeah. And then b, okay, can either be greater than 1, or b can be between 0 and 1. Those are the two states that b can be in. Okay. And so in combination, okay, of a and b, depending on which combination is in place, the combinations between the two, all right, will basically indicate obviously a is greater than 0 will always be above the x-axis, a less than 0 will always be below the x-axis, and depending on which combination it is, then you will either see the function increasing or the function decreasing. All right, so I'm not going to go very deep into this yet. I'm just going to leave it there. Okay, but at least for now, you know that q, horizontal asymptote, a tells us whether above the x-axis or below the x-axis. B, on the other hand, in conjunction with a, depending on which combination is there, will basically show you whether the function is increasing or decreasing. And it's always different combinations, guys. I can't say that when b is greater than 1, it will always be like this. It just depends who b is greater than 1 is matched with. So we will look at specifics, and we will be able to check all of the combinations so that you guys can anticipate what happens if, for instance, a greater than 0 is paired up with b greater than 1. All right, we know that whether you like it or not, always when a is greater than 0, it will always be above the x-axis. Always when a is less than 0, it will always be below the x-axis. But a combination of these two will tell you whether it's increasing or decreasing. Okay, so I hope that makes sense. Guys, that is basically just a taste of exponential function bit of hyperbola function, a bit of parabola, and a bit of linear. Remember that in grade 12 you guys also do cubic functions, all right, which I didn't really touch on here, but these are the algebraic functions that we touch on or we get exposed to in grades 10, and then we pick it up at grade 11, we extend it even further, and then in grade 12 we add on those cubic functions, which basically then cap what we learn as far as functions are concerned for grade 10, 11, and 12. Okay, Sban. Surely my leader, even if it wasn't everything, but we did what we could do for now. I will keep this document and this page, and then I will be extending our knowledge of this in later sessions. But I hope this was beneficial to you, Sbani, just for introductory sake. But please do make sure, if you want more intense awesome stuff, you can go and do intense more awesome stuff, or expose yourself to the rest of the things that you need to. But thank you so much for asking the question. Okay guys, it's 21 minutes past 11, and my goodness, we've been here, we've been up doing the things. Thank you so much, Ndombozuko. Like, I really appreciated the what is that, the ice creams that you sent. Really appreciate that. If you're still here, much gratitude to you. Dialebocha, Diabonga, Dango, Ngosi. Yeah. Okay, guys, I think I'll call it a night now. Yeah, because I just wanted to check what's happening with you guys. Yeah, thank you so much, Swan. I hope so too. That is my hope as well, as I do these things, that learners will grasp the things. I would hate that people are not grasping the things and it's just falling, between the cracks. But I've been getting some messages from some students that have been with me since like the holidays, and it's always nice for me. I had one learner telling me yesterday that at school his teacher was so shocked with his knowledge. Apparently they were doing, what topic were they doing? They were doing exponential, is it exponential equations? Yes, exponential equations, but the trinomial type exponential equations. So before they even taught them, I guess Sir had all the problems put up there, and he started like thumping through and doing the problems, and he was doing them, So the Sir came up to him and he was shocked. He was like, Aibu, and then how is it that you can do this thing? And the learner was like, yo, Sir, yeah, I can, but he knew in his heart that like, yo, it is because he had been attending the sessions with me like during the holiday, and it was very helpful. So he really had mastered some of the concepts already, and his Sir was really pleased with him. So I was quite happy about that. Another learner also indicated to me, he actually sent me 2 successive voice notes, like really expressing her appreciation. He was like, "So I can't thank you enough." The first time he sent me the message, and then the second time he sent me another follow-up message. He's like, "Yo, Sir," and he's like, for all the tests that she has written so far, she's gotten 100%. It's like easy for her. So I was like, yeah, I was very happy with that. So yeah, guys, if that is helping to that extent, I'm happy. At least that's part of what I feel is me making a difference. Okay, guys, thank you so much again. Much love to you all. Please take care of yourself. I noted there my good sister Ndombo said you're writing May, June. This will be helpful to you. Ndombo, just, I don't know if, maybe since you're saying you're writing in May, June, I think maybe what I need to do as well is to probably do a lot more full paper revision sessions with you guys. I hope you are using or utilizing past papers, obviously, to prepare yourself for your May or June. Okay, especially the past May or June papers that they write, because those papers, I must say, they really give them their all. Okay, so maybe I can have sessions that I can go through some full papers with you guys, so that we can also maybe you can engage and ask. Maybe I can also open the guest sort of like aspect of the live, so that we can engage in those particular things in future. But please send me a message and stuff like that. Maybe I can see what day maybe would be preferable where people can be available, where we can do something like that. Yeah, so that we can start knocking down some other important concepts, even if it's not me explicitly teaching a particular concept, but I think through exam papers I can explain certain concepts as we actually meet them in the various papers. So I'll be happy to do that, because at the end of the day it would be nice if we can sit in those papers and be affluent in the papers and be able to write them and do well. Okay guys, thank you so much. Let me love and leave you. Good night to all of you, and thank you again. So you should give us unique or rare questions in our lessons, 1 or 2. I'll do that. I'll do that next time. Don't worry, I'll come prepared next time. Don't worry. In fact, as test dates for even learners are approaching, you'll find that I'll start doing more complex, and we'll start doing exam type questions so that we can get people challenged. But remember, with the teaching at the beginning, because I want people to understand the concept and grasp it, usually I don't really take it to that extent of like putting choke slam questions, Osman, if I get 200% for me, I'll mention you in my speech. Oh, you're killing me. All right, Osman, all the best. Okay, let me love and leave you people. Thank you so much again. It was good. It was really good. Thank you.